Hello physical science student, welcome to a video that's going to deal with some math skills that you need to have in physical science. Now most of you will be doing a maths and you will have either learnt these skills or be in the process of learning it. What I've done here is taken the skills that you need and put them more in a physical science context, and as you'll see I'll be using the equations that we actually use in physical science. So the aim of this is just for you to watch this, reinforce your skills or bring them up to speed so that you're able to do the stuff that we expect you to do in physical science. Let's have a look at what we mean. What we're talking about is it's called here the transposition of formula. Basically it's rearranging equations, and most of you have probably done this in high school or you're doing it in your maths now, but let's just reinforce what needs to be done. And what we do in physical science is a little bit different in maths. Like in physical science, scientists have worked through the years and come up with all these formulas, equations, and they describe what happens in the world. Now they all have a number of letters in them, and if we know enough stuff we can use those equations to predict or to find out what's actually going to happen with other quantities in those equations. So we use equations all the time to find out stuff. For example, find out how far to throw a ball, how fast a car's going, how far something has travelled, all sorts of different equations that we use. And because we're using maths, some people would say that maths is a tool of science because we use it all the time. We're using the same rules that you use in maths, but what's slightly different is instead of having in maths you're probably giving equations that just have x, y and z in them, or a, b, c, we have all these other letters that tend to confuse people. So let's just try and do this fairly quickly. Feel free to pause this at any time and have a think about what I'm saying or what's up on the screen, because it's aimed to help you, but I realise that you also don't want to watch a very long video, so I'm going to go through it fairly quickly. Now you should have learnt that when we're trying to rearrange equations, if we want to move a quantity from one side of the equation to the other side of the equation, we basically do the opposite to both sides. And when we say both sides, that's both sides of the equal signs, because the equal says that the left hand side is equal to the right hand side. So if a number is added on one side, if we want to move it to the other side, we subtract it from both sides. If a number is subtracted on one side, we add it to both sides. Here it says on the other side, but what effectively we're doing is we're adding it to both sides. Multiplying, the opposite is to divide. Divide, the opposite is to multiply. And one you also get is if something is squared, to remove a square, we use a square root, and if something has a square root in it, in the equation, we use the square. And also, by moving something from one side to the other, we change the sign of it. So if you have plus a on one side and you move it to another side, it becomes minus a, and vice versa. Excuse me. So let's go through some examples. I've pre-written most of these, so I'm going to go fairly quickly, but again feel free to pause. Here we want to solve for a, and we've got the formula for force equals mass times acceleration, and a is not by itself, so we might be given the mass in kilograms and the force in newtons, and we're asked what is the acceleration that a mass of 10 kilograms experiences when it experiences 10 newtons of force, and we'd have to work it out. Now if we're just working with the equation, and what I'm going to do in the first all of these except for one is I'm going to rearrange the equation using the formula without any numbers, unless there's numbers in the formula already. And the reason I do this is that this shows you the basics of what we're doing. When we come to the very last one, what I'll do is I'll insert numbers into the formula, but then use exactly the same math skills. And a lot of students often end up doing this. They work out what formula they need to use in a situation, and then they'll put what are known quantities, their values, into the formula and then simplify the equation. And it sometimes makes life a little bit easier. You'll get some practice at doing this, and so you can work out what you need to know. But let's just go through the rules. So the first thing you have to do if you're solving an equation for a quantity is work out what mathematically is happening to that quantity. And here we can see that the A is being multiplied by M. That means that we need to do the opposite to that to move that M from here over to here so that we get A by itself. And the opposite to multiply is divide. So we write the formula, we divide both sides by M, and the reason that we do that is so that those two M's cancel out and we end up with this equation, and generally because we like to have the quantity that we're solving for on the left hand side, we flick it around like that. And there's your answer. And then you would put your numbers in there and you'd work out mathematically what the acceleration is. Let's do another one. In this case it's a little bit different. We've got G. G here is sitting here. Now if you look at this, what mathematically is happening to G? Because we've got to work out what's happening to it mathematically and then do the opposite functions to that to move effectively the M and the H away from it. So sometimes I like to get students just to imagine you're the G in a maths equation. What is happening to you? What's close to you and what's a long way away? Well, the E's over here is a long way away. The M's right next to you. It's not being added to you, it's being multiplied. The H here is being multiplied as well. They're pretty close to you. So we have a multiply by M and a multiply by H, which is effectively the same as multiplying by MH. Hope you understand that. And so what we have to do to get G by itself is divide by MH, both sides. There's our equation. So both sides divide by MH. The M and the H here cancel, like so, leaving us with G. And because we like to swing things around, that's what it looks like. And that's the equation we would use to solve for G. Here we have another one. This is the equation for velocity, final velocity. That U stands for the initial velocity, A is acceleration and time. We're solving for U. So imagine you're U. What's happening to you mathematically? Well, you're standing next to the equal sign, but right next to you is a plus AT. So to get U by itself, we have to do the opposite to that, and minus AT from both sides. What does it look like? Looks like that. And then we cross those out and we come to this, and then we swing that around. Now these are all the lines of working that I do to explain. As you get better at doing this, you can start missing out some lines because effectively you start doing them in your head because they become second nature to you. And so if you were asked to do this and you had a bit of practice, you might just write this. So here's your original equation. Here you've brought the AT across, and there's your answer in terms of the equation. And so you don't necessarily have to show the whole crossing out. I include this in the learning process because you need to know what you're doing and why you're doing it, basically. Right, here's another one. Same equation, but this time we're solving for A. So it's a little bit different. What is mathematically happening to A? Well, in this case it's a little trickier because there's two things happening to it. What are those two things? It's being times by T, just there, but it's also having U added to it. So we need to do the opposite to those two things. So we'll need to divide by T and minus U. But what order do you do them in? That's the question. Excuse me again. Because the order you do them in will be very different. Well, if you do it in a different order than what you should, you'll get the wrong answer. That's a simpler way of saying it. So you have to do them in the order that is furthest away. So what is mathematically furthest away from A, you do first. And then you move progressively closer. Because in some ways it's like peeling away onions. The peel on an onion. You've got to take the outside peel away first before you get to the inner onion, and that's what we're doing in this case. It's also another analogy I use is imagine you're in winter and you've got layers and layers of clothes on. When you come inside from the cold into a warm house, you have to peel off your clothes eventually to take off your coat and your boots and your gloves and things like that. You can't take off your thermals before you take off your coat. You can try, but it won't work. So what do we do in this case? Well, here we go. We go the plus u, which is further from the times t, and so we do the minus u first, and then we do the divide by t second. Why is it a plus u, even though it's just u sitting here in the equation? Because mathematically we can bring this around here, and even though there's no sign there, there's an invisible plus sign. If something's positive in an equation, we don't necessarily write the plus sign, and that's where the plus u is. And so to do the opposite of that, we do the minus u. And there we are, and then we'll cross it all out, and we end up with v minus u equals at. It's still not finished. We've got to get rid of that t. Here it's timesing it, so we do the opposite to times, which is divide, and we cross these guys out, and we're left with this equation here, which can be written as the equation for acceleration. Now that's pretty long. If you do the shorthand version, it would look like this. So if you're starting to do these in your head, you can start skipping some lines. But you still need to show what you've done and why you've done it. Here's another equation. In this case it's power equals voltage, capital V, squared divided by R. We want to solve for V. So what's happening to V? Two things. It's being squared, and it's also being divided by R. So we want to do the opposites of those, which is the square root and the times. But what order do we do them in? Well, the square is the closest to V, so we do that last. And so the first thing that we would do is we do the opposite to divide by R, which is times by R. And this is what we're doing. Here we are. We're timesing by R. Those R's will effectively cancel, like so, leaving us with P. R equals V squared. We then take the square root and the square cancels, and we're left with the answer as such. The shorthand version looks like that, because we don't necessarily have to show the crossing out, but we do have to show that we're moving things around and we're moving them around correctly. In this case we're solving for R, so it's a little bit different. Because R, our unknown, is at the bottom of a division, we have an extra step that generally helps students solve these problems. And the extra step is to move our unknown from away from the bottom here, and the way we do that is by here it's dividing, so the opposite to divide is times, so we bring it across here and times by R. And now we look at this equation and say, well, we still haven't got R by itself, but it's a lot easier to actually get it by itself because it's only being times by P. And the opposite times by P is divide by P. So this little trick here is something to look out for. If what you're solving for is at the bottom of a division or a fraction, you want to move it across to the other side as the first step. And then you do the usual crossing out, walla walla walla, and you get the answer. Okay, and this time solving for S, much more complicated one. Got a couple of things. It's being times by 2a, and it's being added, having u squared added. Now which order do we do them in? Again, hopefully, have a guess. Hopefully you're getting the idea. What's nearest to S is the 2a, so we would do that last. So we want to get rid of this first. Don't worry about the square. The square is part of the package of u, and so if we move u across to the other side, we're effectively moving u squared across to the other side. We're not just moving u, we're moving u squared. Because that square is just for u, it doesn't interfere with what we're doing for S. There's our order, and this is how we do it. So u squared first, subtracted, cross it out, we're left with that, divide by 2a, cross all off the things that we're trying to do, and we're ending up with this equation here, which is our answer, and we put our numbers into that equation. Here we have another one. This one is the equation for kinetic energy, so we have R half mv squared, and we're solving for V. Sometimes this half confuses people. What do you do? Sometimes we might write it as 0.05, or sometimes we write it as a divide by 2 effectively. And so there's three things happening to the V. It's being divided by 2, which is the half there. it's being times by n, and it's being squared. So we have to do the opposite to those, and because there's three things, we have to do them in the correct order. And we could, a couple of them don't matter, but we have to make sure that the last thing that we do is get rid of that square, because that's the closest thing to v. So the last thing that we do is the square root, and we could do either of these two in any order, because mathematically multiplying and divide are the same, have the same priority. Plus and minus have the same priority, but have a lower priority than multiply and divide, and that sometimes confuses people as well. So here I've written it in the way I often write the equation, and that's, instead of having a half there, I have a divide by 2, because divide by 2 is the same as multiplying by a half, and that means that you can see that the opposite to divide by 2 is times by 2, so you bring the 2 across, and that simplifies that. Then you bring the m across by dividing, and that cancels that out, and you want to get rid of the square, so you take the square root, and they cancel out, and you're left with the equation. Okay. Harder one, here we're solving for a. There's lots happening to it. It's being times by it's having ut added to it, it's being divided by 2, which is the same as multiplying by a half, and it's being times by t squared. That t squared can stay together. This square is only t squared. A lot of students want to make a squared as well, but mathematically that square is only squaring the t. A lot of students will fall for that trap. So that's the order we do them in, and we do the opposite. So here's a different way of setting it out. And we bolt right through, do all the cancelling out, move things around, and we end up with our equation looking like that. Okay? So feel free to pause that and talk your way through it if you want. Now sometimes students find it easier if we put the given values into the equation that they want to use and then rearrange the formula. And so, for example, you might be given a question, and one of the things I teach you to do is list the quantities that you are given, and then work out what equation to use. And so in this case we're given an initial velocity, which is u, a time, and a displacement. S stands for displacement. And we want to use this equation here because we want to find a. So we could rearrange this to solve for a using all those skills that we just used, or we can put the numbers in and then simplify. Now the reason a lot of students will put the numbers in is because sometimes it makes life a little bit easier. And so there's the equation we want to use. Now I've taken this half and made it into a divide by 2, simply because that makes life a little easier for some of us. And we put the numbers in. Now because one of the numbers, u, is 0, 0 times by the time, 15, is effectively 0. So it actually gets rid of this bit here is 0, and adding 0 is nothing. So you effectively ignore that bit, and you can make the equation a little bit simpler. You can get rid of the square by just using the value that is 15 squared. And if you looked at this and I asked you to rearrange that, a lot of students would find that a lot easier to rearrange than this or this to solve for a. And that's why there's sometimes an advantage in putting the numbers in. And we do it and we come up with the answer. Voila. Alright, so what we're going to do in class is we'll give you some sheets that will ask you to rearrange equations, and then there'll probably be a little quiz for you to do just to make sure you've learnt this skill. Hopefully that hasn't confused you too much, and it's reinforcing what you're actually learning in maths, because sometimes it's hard to know that maths is important, but it is, and your math skills are necessary to succeed in physical science. Alright, cheerio!